welcome to our presentation. Today we're going to talk about the periodic table. I'm Rosa.
I'm Yulissa.
I'm Madeline.
Alright, and let's get started. So first I'm going to talk about the history of the periodic table. The periodic table started since 1869 and it was invented by Dmitri Mendeleev. In 1886 through the 1900s, there was discoveries of different rations, gases, and elements. From 1903 to 1932, the discovery of atoms, electrons, neutrons, and atomic nucleus came along throughout the years. And then lastly, in 1945, when Glenn Seabury identified lanthanides and actinides, which are usually placed below the table. And then throughout time, multiple people contributed to the periodic table. It wasn't just Dimitri who did all of this. It was different inventors who kept adding onto the periodic table. And then throughout time, more qualities have been adopted, which is why we use it for various reasons now. Right, and this is just a brief picture of what the periodic table is. It has the elements, and then their mass, and then the sections they're in, and then it has all of the colors separated between what different elements and gases they are. Alright, so what is a periodic table? The periodic table is a table of chemical elements arranged in order of atomic number. It's usually in rows so that the element with similar atomic structure, hence similar chemical properties, appear vertical in the columns. And then it consists of, like I said before, atoms, protons, masses of the element, and then there's different groups or families within the periodic table. And then the way that we use it now is mostly in chemistry classes, and then a lot of people use it just to fully comprehend these atoms or elements that are included in the periodic table. Alright, so I'm going to talk about some groups that are included in the periodic table. The first group would be the alkaline metals. The second group would be the alkaline earth metals, and then the group 11, it jumps to group 11, which are the Coinage metals, and then group 15 is the Pentategens metals, and then we have the Chalcogens, and then the halogens, and then the noble gases. So these are all the groups that there is, and then these groups go from the two bottom ones as well, which are separated from the whole periodic table, which are the lanthanides and the actinides. Alright, and then just a little bit more on the periodic table itself. The horizontal rows in the periodic table are known as the periods, and then the different periods are the period 1, which only have 2 elements within it, and then periods 2 and 3 increase up to 8 elements. As you see, periods 4 and 5 slowly go up to 18 elements, and then lastly, for periods 6 and 7, it can only go up to 32 elements because the 2 bottom rows are separated from the rest to the table also belong to it. And then we're just going to watch a brief video basically going over everything I kind of just talked about using their examples and their pictures.
As you move from the light elements to the heavy elements, you keep periodically coming across the same properties, which is why it's called the periodic table. The recurring properties are organized so that you can easily see similarities between elements. The periodic table is arranged in periods and groups, going from the light elements at the top to the heavy elements at the bottom. The rows going across from left to right are periods. Elements in the same period all share something in common. They have the same number of energy shells. Each new period row represents a new shell. Elements in the first period have 1 shell, and as we go down, the shells increase. Hydrogen is in the first period. It has 1 shell. Potassium is in the 4th period and has 4 energy shells, as do all the other elements in this period. The columns going down from top to bottom are the groups. Elements in the same group also have something in common. Elements in the same group have the same number of electrons in their outermost shell. The electrons in the outer shell are called valence electrons. This just means that these are the electrons available for reactions and bond formation. The number of electrons in the outer shell governs elements' reactivity, which is why elements in the same group have similar properties. The group number can tell you how many electrons are in this shell. For example, let's look at group 7. Fluorine, chlorine, iodine, bromine, and astatine. They all have 7 electrons in their outermost shell and all exhibit similar chemical characteristics. The properties show a gradual change going down the group as we go from period to period. So, if we look at group 7 again, we can see that they are each in a different period in the periodic table, telling us that each element in this group has its outer electrons on a different shell. So, chlorine is in group 7, period 3. Therefore, it has 3 energy levels with 7 electrons in its outermost shell.
So now I'm going to talk about a specific element, which is going to be helium, which is located on group 18 in the periodic table. And then it has been drawn out here on the board to go step by step about what each thing on the element means. So the main thing we want to focus on is on the helium element, which is He, obviously stands for helium. The number 2, which is located on the top of the element square, is going to be the atomic number, which also equals the number of protons as well as the number of electrons. So that top number, whether it's any of the elements, is always going to equal the protons and electrons. And then we have the number on the bottom. The number on the bottom is always going to be that mass number. So on all of the elements on the periodic table, it has a mass on the bottom, and that's what the element weighs. And then to get the number of neutrons, you just use all the numbers you have in your element. For example, here you would do the mass for the number of protons, which is 2. And that gives you the number of neutrons, which in this case would be 2.
I'm going to talk about the groups, and Rosa already talked about it, but we're going to go again in depth. Just to reiterate, a group is the column on the periodic table. And now we're going to watch a video again going in depth about the different groups of the periodic table.
The periodic nature of elements, the periodic table explained. Although the periodic table of elements looks complex, it is easier to follow once you learn how to use it. First, the letters are symbols. Each box represents an element. Each element is made up of the same kind of atom with a specific number of protons in its nucleus, the atomic number. For example, H represents hydrogen. All hydrogen atoms have 1 proton. The symbol He represents helium. All helium atoms have 2 protons. The elements are arranged by increasing atomic number. The atomic number displays how many protons are present in the nucleus of the atoms. The table is also very colorful. Each box is color-coded to show whether the element is a metal or non-metal, indicating the specific type. If you take a closer look at one element in particular, you will find its atomic number, atomic mass, element name, and element symbol. Looking at the overall table again, you will notice that it is made up of columns and rows. The columns are known as groups, and the rows are known as periods. All elements in a group have similar characteristics. These characteristics will tell you how many valence electrons, the electrons in the outer shell of the atom, are present in that atom, giving you an idea about how they bond. Here are the element groups and the number of valence electrons present. Count from the left, but skip over the transition metals because these are a little more complex. The periods display the number of electron shells that are present in the atom. We will not get into much detail about this, but notice that as you move down through the periods, the number of electron shells will increase. Another trend you will notice is the size of the atom, or the atomic radius. As you move down through the periods, the atoms become larger, increasing the atomic radius. As you move from left to right across the groups, the atoms become smaller, decreasing the atomic radius. The opposite is true for an atom's ionization energy, or how readily an electron can be removed from an atom. As you move down through the periods, the ionization energy will decrease. As you move from left to right across the groups, the ionization energy will increase. Knowing the basic properties of the periodic table will be beneficial to you throughout your school career. The periodic table allows scientists to determine the atomic structure of elements and predict how they might behave. Once you have a firm understanding of the periodic table, you will be able to apply it to experiments in your own classroom.
So we're going to talk about the metals now, and the metals are the red sections of the periodic table. Some characteristics of metals are they are often solid, they're good conductors, they're malleable, which means they can be hammered, and they also lose electrons easily. So again, just to reiterate, the metals are the red portions of the periodic table. So as you can clearly see, most of the periodic table is made up of metals. So now, nonmetals. The nonmetals are the blue section of the periodic table, and some characteristics of the nonmetals are they are soft, and we remember that metals are hard. So these are soft, they're poor conductors. Some of them are liquids, and they gain electrons quickly. So if we go back to the previous slide, we can see their exact opposite. So metals are solid, good conductors, malleable, and they lose electrons. Again, nonmetals are soft, poor conductors. Some are liquid, and they gain electrons quickly. So they are the blue section, the nonmetals. So we have hydrogen over here, helium, and then all the other elements that are nonmetals. So the noble gases, this is just reiterating where the noble gases are. The noble gases are this purple section. So they're these right here on this last section. And the noble gases more specifically are helium, neon, argon, krypton, xenon, and radon. So now we're gonna watch a video going more into depth on the metals and the nonmetals.
Let's take a look at the metals, nonmetals, and metalloids on the periodic table. On the left, we have the metals. Then in between them, we're going to find the metalloids. And then on the right, we'll find the nonmetals. Do watch out for hydrogen though. It is on the left-hand side with the metals, but it is a non-metal. So let's try one of these. So calcium. Is calcium a metal, non-metal, or a metalloid? Well, you can see that calcium's on the left-hand side of the periodic table, so that's going to make it a metal. Let's try another one. Sulfur. Since sulfur is on the right-hand side of the periodic table, we know that it's a non-metal. Let's try one more. Tellurium. You can see that tellurium is that juncture between the metals and the nonmetals, and that's going to make it a metalloid. Finally, let's look at one more, hydrogen. You might remember that hydrogen is the one that's a little bit tricky. Even though it's on the left-hand side, we classify it as a non-metal. If you're wondering about the elements found below this section of the periodic table, those are all metals. This is Dr. B, and thanks for watching.
So we're going to talk now specifically about how and when the periodic table is used. So it organizes the elements and puts them into different sections and categories so it's more easily read. It can also be used to predict future elements. So when you combine one element with another, you're creating other elements. It is also used by students and scientists. So it's really, really critical for students to be able to understand and be able to use the periodic table, because a lot of science is based around chemistry, and it is also used to help figure out how to balance an equation. So when you're balancing an equation, you're taking one element and another element and you're putting those together. So it is also used for that.
Okay, so now we're going to be talking about the two bottom periods at the bottom of the periodic table. And so what we know about them is that they're not placed in the table because it messes up with the arrangement of elements. And this is just basically scientists not wanting them to put it, because this would extend the two bottom periods all the way like to the end. And then the row pertaining to the sixth period pertains again here, the lanthanides, and then the last one, it pertains to the actinides. And this is the arrangement. And right now
in covalent organic chemistry.
we're going to be showing you a video about explaining the periodic table and the groups and stuff.
Just in covalent organic chemistry, we'll get to that. Down below, in their own little island, are the lanthanides and actinides, metals that were largely undiscovered in Mendeleev's day because they're so similar that it's next to impossible.
So in the periodic table, there's various relationships that you can find. And so we know that we have diagonal relationships, which are shown here. And they have similar size and electronegativity, which we saw that as it goes up, the element gets smaller. And then we also, like we explained before, there's groups and then there's periods. And so the most important elements to us are genops, in short. Genops. Okay, so the most important elements to us are, we can put it in short, genops, which are carbon, hydrogen, nitrogen, oxygen, and phosphorus and sulfur. So these are the 6 elements that are very important to our living as human beings and animals and any organism that's living. And so now, before we get to the slide, I'm going to explain the shells and the atom setup. Okay, so now we're going to be talking about the valence electrons like we discussed here in the how we're going to discuss. We're just going to go in a little bit in depth. So we're going to start off with the core, and that's where the protons and neutrons live. And then atoms have shells, and so I'm going to be talking about how many electrons can be in each shell. So in the first shell, it can hold 2 electrons. And then the second shell, it can hold 4. And the third shell, it can hold 8. And then it keeps going. So how you would write this is n equals 2, n equals 4, n equals 8, and then as you continue, n equals 8, n equals 16, n equals 16 as we go on. Usually we don't have a lot of atoms that go past 8, so we don't really need to know a lot about this, so we need to focus on this mostly. So yeah, so protons, neutrons, and then electrons. And so we can see in this slide how it works out. So carbon, it has 6 protons and 6 neutrons. And since we know that they're the same number of protons equal electrons, so we know that there's 6 protons here and then 6 electrons. So in the first shell, there's 2 electrons, and then the other ones, there's 4, so it all equals 6. And so this is the carbon atom, and then as we go on, we know that hydrogen has 1 proton. So we're gonna know that it only has 1 electron. And then as we go on, we could see this, the nitrogen, oxygen, and these are the main elements of life. So lastly, I'm gonna be talking about hydrogen, because hydrogen is basically the most important element, and it is everywhere. So in specific, it's in clouds, it's in stars, it's added in fats and oils, in foods and not foods, and can exist as gas in room temperature. So right now, there's hydrogen in this room. And then when hydrogen gas burns in air, it forms water. This is the end of the presentation, and so we just want an overview of what we learned today. Today we learned about the periodic table and everything in its elements, from its groups and periods, how it's formed, valence electrons, and the different characteristics that each group has in the element. And that is our presentation.